quality management. So first, definition of quality. Because we use different terminologies, for example, quality versus grade. For example, we say this product is of high grade or this product is of high quality, right? Both are entirely different things. Quality means a product that is fit for use, fit for purpose. So if a product is fit to perform the intended function, we say it is of high quality, right? Whatever the intended function is. If it doesn't perform the intended function, we say the quality is poor. On the other hand, grade is category of the product. For example, you can have high grade, you can have medium grade, and you can have low grade. High, medium, these are different categories or different classes of the material or the product, and high, medium, low is acceptable. But quality can't be low. Low quality means product is unfit. You understand, everybody? For example, let's take an example of glass. So you use glass in your house windows, and if the glass does not break and it performs its intended function, we say the glass is of high quality, right? High quality. But within the same glass, we have different grades, let's say high grade, right? Medium grade and low grade. High grade is, let's say, 30 mm in thickness. Medium grade is, let's say, 15 mm in thickness. And low grade is, let's say, 5 mm in thickness, right? So grade tells you the dimensions and properties of that material. So high quality, high grade glass, it is also good, right? Medium grade is also good, and low grade is also good. Who would like to answer how 5 mm is good, is as equally good as 30 mm? Who would like to answer? How? How 5 mm glass is equally good as 30 mm? Anyone, please?
It depends on a product where we are using.
Absolutely right. Fantastic. It depends where we are using the product. If the requirement is 5 mm and you're using 5 mm grade, it's perfectly fine, right? So low grade material is perfectly fine as long as it performs the intended function. So that's the difference between quality versus grade. Okay, if I talk about quality process, we divide it in 3 steps. Step number 1 is plan quality. Step number 2 is manage quality. And step number 3 is control quality. Let me label these. Plan quality, manage quality, and control quality. Here we will be focusing on the planning part of quality, right? Okay. We also use 2 different terminology. One is called quality assurance and other is called quality control. Anyone, please, what's the difference between these two? Quality assurance versus quality control. Anyone, please? What's the difference? Any idea?
One is procedural and one is
Right?
I think quality assurance is a lot to do with documents and
Okay.
and making policies and setting up the framework for quality, whereas quality control is potentially an activity and more so physical work.
Okay. Perfect. So yes, more or less correct. Quality assurance focuses on having right procedures, right processes, right frameworks in place before you actually start building the product. And quality control is performing testing on the product to make sure that you are building the right product. So focus of quality control is product, and focus of quality assurance is processes. So you assure quality before you actually start building. And how you assure that? Having right resources, right? Having right processes, having right equipment, right people. Okay, so this is called quality assurance. So preparation before you start working on the product. And quality control is when you are developing the product, right? You do all the testings and verification. That is called quality control. You're keeping the product within limitation by performing all the tests and finding the deviations. Okay, right. Who would like to answer? Training employees, what is this? Training team members, quality assurance or quality control?
It's assurance, I think.
It's quality assurance, right? Having right resources, right processes, right methodologies, right people, right equipment. This is all part of quality assurance. Okay. Audit, what is it? Quality assurance or quality control?
Quality controls.
And okay, how it is quality control?
So we are performing the testing for that process or anything. So it might be some problem.
Okay. So you're saying we are performing what of the process?
We are checking the output of the product.
Output of the product. Previously, you used word process.
Process. Yes, sorry, process. That means
Okay.
product.
If it is process, then it would be quality assurance. So audit is an example of quality assurance. It is one of the quality assurance activity, not quality control, right? You're checking, you're making sure that you are following the right process. So it is quality assurance, okay? Perfect, wonderful. In quality planning part, this one, the first section, which is plan quality, what we do is we develop quality management plan like other knowledge areas, quality management plan, right? We determine cost of quality. We develop quality matrix. These three things are done when we are in the quality planning stage. So let's start with the first one, quality management plan. Who would like to answer what do we do or what do we add in quality management plan? Anyone, please. Anyone, please. What do we add in quality management plan? Anyone, please.
Policies, procedures,
Perfect.
templates,
Quality policies,
definitions,
templates, tools and techniques.
it seems like there's a reoccurring theme with all of these management
Absolutely.
plans.
Absolutely. All management plans, the purpose is same, standardization. Templates and formats, units of measurement, roles and responsibilities of different actors regarding quality, quality-related definitions for shared understanding, right? Again, the purpose is standardization, documenting all the guidelines so that as a team, we are on the same page and we have shared understanding on how, as a team, we will be managing quality of the product, right? Within the quality management plan, we determine cost of quality, cost of quality related activities. So see, previously we talked about cost in the costing section, and we determined cost of the activities, right? Project activities, plus cost of any risk in the form of reserves. But we did not include cost of quality related activities, means cost of inspection, cost of testing, cost of defects. You understand, everybody? Right? So what we're gonna do, we're gonna estimate the cost that is required to perform these quality related activities. So we categorize this cost in two different categories: cost of conformance and cost of non-conformance, right? Conformance cost is the cost that you incur to make sure that product remains defect-free. You don't let defect happens. There are two subcategories under the conformance cost: cost of appraisal and cost of prevention. Prevention cost and appraisal cost. Okay. Prevention cost. Prevention cost prevents defects. How we can prevent defects in a product? Anyone, please? How we can prevent defects? This is similar to prevention is better than cure. So how we can prevent defects in your product? Who would like to answer?
Regular inspections during production.
Okay, regular inspections. Right, okay. What else? That's more like appraisal.
Align with the scope and requirement.
Sorry, what? Aligned with?
Scope and requirement.
Okay. What else? We're talking about defects. Even if it is aligned, still we can have defects. How we can avoid defects?
Quality control.
What do you give me any activity? What do you mean by quality control?
Well, testing the batch at the end of production. So
Again,
quality
testing is like, so look at it
It's
from
not
your personal
preventative.
perspective.
Right.
So by testing, you're not preventing defects.
Okay.
By testing, you're diagnosing already existing defect, right? You're not preventing it. How you can
you're right.
prevent disease?
Vaccination.
How you can, sorry, what?
Vaccination.
Vaccination, okay. What else?
So when you're talking about preventative cost, what you're talking about is the framework in which you deliver. So say, for example,
Yeah,
I'm delivering a software
absolutely.
product, I'll have a set of minimum standards that the developers have to meet
Absolutely.
during the development
Absolutely.
cycle.
That's right. Having the right lifestyle, healthy food, right? These are the things which will keep you away from diseases. Same is the case here. Right framework, right processes, right? Right resources, skilled people, right? All of these things, they will make sure or they will prevent defects. So all the costs that you incur on these activities, that is called prevention cost. Cost on defining the right framework, cost on hiring right resources, training employees, all of this is called prevention cost. And then we have appraisal cost, all kind of inspection, testing, right? Destructive testing. These are called appraisal cost. All kind of tests that you perform on product. Similarly, non-conformance is also divided in two categories: internal failure and external failure. Okay, internal failure. Let's say you build something which has defect, and now you need to rectify that. So defects repair. That is internal repair. Any kind of waste or scrap. So these are your internal failure cost, right? If you need to rectify something, if you need to redo it, you need to incur cost. That is called internal failure cost. And then we have external failure cost. Let's say you build the product, you send it to customer, and customer send it back to you. So warranty costs, cost of claims, right? This is called external failure. So all are these 4 different categories of the cost that you calculate and you add in your cost baseline or your budget, right? So this is step number 2. The last thing that you do is in quality planning, you develop quality matrix. Testing is one of the essential components of ensuring quality. So what you do is you develop quality matrix. Matrix means how you will be measuring quality. So we will be measuring quality with the help of different tests. So what I'm going to do, we will be writing all the tests here, right? So for example, what we want to test, let's say I'm going to test product durability. Name of test, which test I will be performing to test the durability. ABC test, whatever test is, it varies from product to product. What's the frequency of this test, right? After a week, once after each batch, fortnightly, whatever the frequency is, right? What's the threshold? What's the acceptable number for this test? Is there any tolerance? Right? Now, this is called your quality matrix. Quality matrix contains detail about all the tests that you will be performing on your product, right? So durability test, let's say soundness test, there are different properties of the material. And if you're working on an IT project, your KPIs would be entirely different, right? So this is your quality matrix. Once you develop all these things, you're done with the planning part of quality, right? Then you jump into the execution part, which is not part of this lesson. So that's all with regards to quality management. We talked about definition of quality. What is quality? Quality versus grade. We categorize quality in 3 steps: plan quality, manage quality, and control quality, right? We talked about difference between quality assurance and quality control, right? Typically, we use word quality assurance, but in 6th edition of Project Management Body of Knowledge Guide, PMI renamed it to manage quality. So this is exactly same as quality assurance, but they have renamed it to manage quality, okay? Okay, within planning, we perform 3 activities. The first one is we develop quality management plan, all the policies and procedures and everything. Second, within the plan, we calculate cost of quality activities, and third, quality matrix. I hope it is clear. If you have any question, please feel free to ask. Next part of our discussion is continuous improvement. Continuous improvement. So we need to continuously improve quality of the product, right? Performance, efficiency, and everything for use various techniques for continuous. For example, first one is Edward Deming's PDCA model. Deming's PDCA model. This is also called Deming's wheel, right? Deming says if you want to improve something, follow this 4-step model. First, plan something, whatever you want to change, whatever you want to improve, plan it, then do it. After doing, check it, and then act. Okay. So plan means, let's say employee's performance is not up to the mark and you want to improve it. So you come up with an improvement plan. And improvement is, let's say, you say, okay, let's allow work from home, flexibility. And maybe by doing this, employees' performance go up. So you will be planning that flexible hours. This is your plan. Deming says before you implement throughout the organization, so do step is experimentation. Implement the change at small scale. You understand, everybody? Maybe you're implementing this in just one team, small team. After some time, check the result. Check step, you study or analyze result of your experiment. If result is favorable, act. Act means large scale implementation. Implement the change throughout the organization. You understand, everybody? If results are not favorable, go back and replan. So this is called Deming's wheel. We implement a change with the help of 4 steps. First, plan what you want to change. Rather than implementing it the entire organization, try to implement at small scale. Study your experiment, result of your experiment. If results are favorable, act. Act means implement throughout the organization. If not, go back, refine, and repeat the cycle. This is what we call Edward Deming's PDCA or PDSA model. S stands for study for continuous improvement, right? We also use other techniques for continuous improvement. In order to improve something, first of all, you need to understand the root cause behind that. So we do root cause analysis. And for that, we use fishbone diagram. This is also called Ishikawa diagram. Cause and effect diagram or analysis. YY analysis. These are different names for this diagram. The purpose is to find root cause of the problem, right? So how we develop that? So this is your fish. This is your fish head, right? On fish head, you write the problem, whatever problem. Let's say problem is poor quality of product. You want to analyze why quality of product is poor. So you will be analyzing all potential factors that could contribute to poor quality. For example, poor quality could be because of poor processes. It could be because of poor material, poor manpower, poor equipment. You can add as many factors as you like. So these are your key factors. Then you ask, okay, why material? What's wrong with material? Because material is outdated or expired. You're using it after its expiry. Since it is called why analysis, you keep on asking why again and again until you find the root cause. So why poor quality? Because of poor material. Why poor material? Because it was used after expiry. Why it was used after expiry? There was no inspection. Why there was no inspection? We have no inspection protocols. So one of the root causes of the problem is that we need to have material inspection protocols. You understand, everybody? So by asking why again and again, you find the root cause of the problem. Same is the case for other one. Let's say you're saying why manpower, right? They are not skilled. Why they are not skilled? There is no job alignment or skill alignment. Why no? Let's say no HR or no resource. So we need a resource for this. So you keep on asking why again and again, and you come up with main root causes, then you address those. So this is your fishbone diagram. There's a similar one that is similar to this that is called 5 why analysis. 5 why analysis says if you ask why 5 times, you'll find the root cause, right? Somebody failed the exam. Why? They could not attend the course. Why? They were busy in work. Why? Right? They could not do their job or work earlier. So if you keep on asking why again and again, you'll find the root cause of the problem, right? Okay. We also use a histogram to know the root cause. Histogram is a chart that shows what's wrong with your process or what's wrong with the problem that you're talking about. Histogram. So on histogram, you map problems. Let's say you're manufacturing something. Please pay attention, everybody. You're manufacturing something, and during manufacturing, you have multiple problems, right? So on histogram, you plot the frequency of problems. Let's say you take a sample, and that sample says there is something wrong with the color of the product, okay? You understand, everybody? So I'm going to draw a dot here. This purple dot shows something is wrong with the color. You take another sample, and that says there is something wrong with the dimension of the product. You draw another dot. You take the third sample, and third sample says, yes, there is another problem with the dimension, okay? You take the third sample and a fourth sample, and fourth sample says there is something wrong with the weight of the product. So this is third type of defects. So on a histogram, you plot different types of defects in your product. And at the end, let's say you're getting something like this. And you need to tell me, what is it? Who would like to answer? What is it? What's your understanding by looking at this?
Major problem caused by the dimensions.
Absolutely right. So you'll understand what are the recurring defects, what are the major defects, where you should be focusing on. So histogram is the chart.
In the measuring, keeping the exact dimensions.
Yeah, I mean, if you could handle the dimension problem, you'll get rid of most of the problems. Like most of the product pieces have a dimension related problem. You understand, everybody? Any confusion about how a histogram is used? Histogram plots frequency of defects. And as a result of that, you get to know what are major defects. There is another form of histogram, and that is called Pareto chart. Pareto chart is similar to this. Like this. And what I'm going to do this. And you need to tell me what I did here. So I just ordered them in a descending order. So a Pareto chart is a histogram in descending order. So you can visually see which defects are recurrent, where you should be focusing on. Pareto also presented 80-20 rule. like 80% of the impact, 80% of the contribution is because of 20% of defects. As you could see, which one is contributing more in the overall defects number? Who would like to answer? Which one is contributing more? Defect type A. Am I right, everybody? Right? Means
Yeah.
80%
Yes.
of the contribution is because of type A defects. Most of the contribution is because of type A defects. So if you want to get rid of most of the impact, get rid of these 20% of defects. If you could handle type A defects, most of your problem would be solved. So this is what we call Pareto chart. If you have any question about it, please feel free to ask. Okay, then we have two more techniques that we use here. One is called control charts. Control charts are used to study accuracy of your processes, right? Let's say you're manufacturing something. So what you do is, this is your control chart. It has an upper control limit and it has a lower control limit, right? Upper control limit and lower control limit. And then it has a mean line, median line. Let's say you're developing a physical product and the ideal weight of that product should be 40 milligram. That's the ideal. Upper control limit is 41 mg and lower control limit is 39 mg. This is also called tolerance limit. You understand, everybody? You'll take a sample and let's say you weigh it and it is 40.05 mg. So you'll plot it here. You understand, everybody? You'll take a sample, right? Measure the weight and plot it on this graph. So you keep on plotting all different samples on this graph until and unless you see something that is out of limit. So if a product is out of your limit, it means there is something wrong with the process. So we call it out of control process. So control chart is used to see if your process is producing products within the tolerance limits or outside of the tolerance limits. You understand, everybody? That tells you the productivity of your process. And if it is producing outside of the process, means you need to recalibrate it. You need to do something. So we're talking about continuous improvement. Before you continuously improve, first of all, you need to see if there is something wrong with the existing product or process. So this tool helps you study your process. Not just this, in addition to that, if you see, let's say, 7 consecutive points on one side of mean line, this is called rule of 7. If you see 7 consecutive points on one side of the mean line, this is called rule of 7. Rule of 7 says if 7 consecutive points are on the one side of the mean line, it means there is something wrong with your process. Your process is tilted towards one side of the mean. You understand, everybody? Does it make sense? Ideally,
Yep.
let's say the weight should be 40 mg. You take a sample and it says it is 39.1, 39.2, 39.3, 39.2, 39.4. It means the process is tilted towards one extreme. But what's wrong with it? Who would like to answer? It is still within the limit. What's wrong with that? Your tolerance limit was 41 mg to 39 mg. It is still within the limit. What's wrong with that? Why you're worried about it?
You're
Does it
limiting
mean
your
that
tolerance.
utilization.
One by one, please.
You're limiting your tolerance to 1 mg because you're basically from 40 to 39. You're not utilizing the 40 to 41 side of the bracket, tolerance
Yes,
bracket.
absolutely, absolutely. And also there is a high possibility that this will go out of process.
Yeah,
You understand?
it's trending downwards, isn't it?
Absolutely right. So this is how control charts are used to study the process and to see if there is any correction is needed before something bad has happened. Right? This is your control chart that we use to analyze our processes. We also use another technique, and that is called scatter plot. Scatter plot. Okay, let's say in the previous diagram, which was fishbone diagram, we concluded that poor quality is because of poor manpower or poor processes, let's say. So we have two variables here, right? One is quality and second is process. Am I right, everybody?
Yeah.
So quality, we call it dependent variable, or let's call it Y. And this is independent variable. So we have two variables, and this diagram shows us there is a relationship between poor quality and poor processes. So scatter plot is a technique that we use to mathematically establish or substantiate that relationship. So previously we saw that. Now we want to mathematically substantiate relationship between X and Y. That's what we want to do. Right? How we do that, please pay attention, everybody. So X is, what is X? X is, let's say, processes, quality of process, and Y is quality of product. Right? And we want to see if there is a relationship. Let's see if through mathematics we can establish that. So we will be doing experiment by keeping the quality of the process very low. Let's say quality of the process is 1. When the quality of process was 1, we saw that quality of product was 5, just a random number. We double the quality of process, and what we concluded, we got that quality of product goes up. We increase it again, it increased again. We kept on increasing, and we saw a corresponding change or increase in the quality of product. What does that mean? Who would like to answer? What does that mean? What's happening here?
There's a proportional relationship between process and quality.
Absolutely. There is a proportional relationship between these two variables. If I draw a graph here, right? So I'll be having, so let's say here I have Y, here I have X, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, not, let's say this is 1, 2, 3, 4, 5, 6, 7, 8. This is 5, 10, 15, 25, 35, 40, and so on. So if I plot this here, please pay attention. 1 and 5, the first point, where I should be writing the point 1. 1 on x-axis and 5 on y-axis. I think it should be here. Am I right, everybody?
Yep.
The first point. Second point would be here. Third point would be here. Fourth, fifth, sixth, seventh, eighth. Am I right, everybody?
Yep.
If points are closer on the scatter chart, it indicates a strong and proportional relationship between two variables. If points are closer to each other. And let me do another experiment. And the experiment is, instead of X, what I'm going to do is, I'm going to take another variable, let's say Z. Or let's say X this time is manpower. And Y is quality. right? So it was 1, 2, 3, 4, 5, 6, 7, 8, and so on. When manpower was 1, this was 45. When manpower was 2, this was 30. When manpower was 3, this was 5. Manpower increased to 4, this is 50, right? Manpower is 5, and let's say this becomes 20. Manpower is 6, let's say this is 5 again, right? Or let's say 10, right? 35, and so on. Now let me draw this as well. So 145 somewhere here. Am I right, everybody? Clear? Can you see it, everybody? 145. Okay, 230 would be somewhere here. 35 is somewhere here. 450 is here. 520 is here. 610 is somewhere here. 735 is here, right? So you can see green points are scattered all over the chart. So if points are scattered, it indicates a weak relationship. If points are closer, it indicates a strong relationship. You understand, everybody? Does it make sense? So you can mathematically substantiate relationship between two variables to see if they are actually causing the problem. So here, by doing this experiment, we'll get to know poor processes are actually contributing to the poor quality. Poor manpower is not contributing to the poor quality of product. You understand, everybody? This is how we use scatter plot. On a scatter plot, if points are segregated, it indicates weak relationship. If points are closer to each other, it indicates strong relationship. Any question about it? Anyone, please? With this, we're done with continuous improvement section